Hi, hello everyone. Welcome to Vision Classes. It's a classes for IGCSE, GCSE, AS and A-level student. So today we have to discuss equilibrium of forces question. It's a AS and A-level mechanics conceptual based question. So here we have the coplanar forces of magnitude 52, 39 and P act at a point in the direction shown in the diagram. Here we have given this diagram and this system is in equilibrium. So we have to use equilibrium of forces concept, means net force acting on a point is basically zero. So and then we have to find out the P and theta. So first of all, we have to resolve here forces P. So along the x-axis, along the y-axis. So along the x-axis, we will get, this is theta, right? In terms of theta, it's a adjacent angle, right? Adjacent angle is cos theta. So we can write P cos theta, and along the y-axis, it's a downward one, right? And it's a opposite force. So it will be P sine theta. So once you're done with resolving, you can use the summation of f of x is equal to 0. So here P cos theta is equal to 39 Newton, right? Means this is going leftward, 39 force on the rightward. They are equal, isn't it? Because this system is in equilibrium, isn't it? So we have to resolve along the x-axis, along the y-axis. Now along the y-axis, it will be summation of f of y is equal to 0. So here we have a y-axis forces 52 Newton and downward it's a P sine theta, isn't it? So P sine theta is equal to 52, fine. We have to find out, P. So to find out P and theta, we can take firstly ratio. So P sine theta upon P cos theta is equal to 52 upon 39. So PP get cancelled out. So sine theta upon cos theta is basically tan theta, isn't it? Tan theta is equal to 52 over 39, right? Then nextly, to calculate theta, you can use the tan inverse of 52 over 39, which is equal to theta is 53.13 degree. That's it. Okay. So once you got theta, you can substitute in any of the equation and to calculate the P. So here P sine theta is equal to 52. From the f of x equation you can use, right? So P is equal to 52 upon sine of 53.13, fine. And P we will get, it's a 65 Newton if you put out in the calculator. So here just we have used equilibrium of forces concept, resolving the forces, fine, breaking down the forces into horizontal and vertical component, isn't it here? And then we used a little bit of trigonometry to calculate the value of P and theta. That's it. This is 4-mark question. If you write this way step by step answers, you will get out of out. To know this kind of tips and tricks, subscribe to our channel as well. Enjoy the math.